Welcome back to Excellence. I come with a new video. In this video, I'll share basically the flashcards of your CIE levels, Physics, chapter number 3, Kinematics. This is only just for AS level, so let's begin. So define speed, the equation used to calculate speed and the respective SI units or the SI base units of speed. So now the speed is defined as the rate of change of distance. The equation used is speed is equals to distance over time, and the SI units are meter per second, where the meter is the SI unit of distance and second is the SI unit of time. Now you have to define displacement. So displacement of an object is the distance it has traveled in a given direction, so it is a vector quantity with both magnitude and direction. We have already discussed that displacement is a vector quantity while the vector means which have magnitude, unit and specific direction. It means speed with a direction. Define velocity, the equation used to calculate velocity and the respective SI or SI base units. In your AS level, especially in your AS Physics and A2 Physics, you need to acknowledge how to convert non-SI base units into SI base units, similarly for velocity. So the velocity of an object is defined as the rate of change of displacement or speed in a given direction, making velocity a vector. It means velocity is a speed with a direction, and velocity have a magnitude, unit and direction. The equation used is velocity is equals to change in displacement over time or displacement over time. And the SI units are meter per second, meter for displacement and second for time. Define acceleration, the equation used to calculate acceleration and the respective SI or SI base units of acceleration. So acceleration is defined as the rate of change of velocity, making it a vector. What does it mean? It means that acceleration also have a direction. The equation used is acceleration is equals to change in velocity over time. And SI units are meter per second square, where the square on the second means for velocity you have SI unit of meter per second and for time you have second. When this second of time will go upward, it will make s -1 will become m s -2. What does a straight horizontal line represents on a displacement time graph? Yes, in AS you need to acknowledge displacement time graph and velocity and acceleration time graphs. So remember that whenever there is a horizontal line on the graph of displacement time, you will always observe that the object is at rest or the object is stationary. The word stationary means the object is not moving due to no external force which makes an object to move. It means that it is on rest. What does a line with a constant non-zero gradient represents on a displacement time graph? It always means that an object is moving with a constant velocity. The constant velocity means that the velocity remains same and is not changing. What does a curved line represent on a displacement time graph? If the curved line represent on a displacement time graph is increasing or the gradient is increasing, it means the body is accelerating or have an acceleration. And if the gradient is decreasing or the curved line decreases, it means that the object is decelerating or there is deceleration. What does a straight horizontal line represents on a velocity time graph? It means that the object is moving with a constant velocity. It means that the velocity of the object which is moving is not changing and remains the same. What does a line with a constant non-zero gradient represent on a velocity time graph? It means that the object is accelerating, meanwhile, the gradient of the graph must be positive or is decelerating, whereas the gradient or the slope of the graph must be negative. What does the area under a velocity time graph represents? As you have already discussed that velocity is equals to displacement over time, hence displacement is equals to velocity multiplied by time, whereas the velocity on the y-axis and time on the x-axis on the graph represents the area under the curve is known as displacement. What does the area under an acceleration time graph represents? It simply represents velocity because acceleration multiplied by time will give you the value of velocity. As you have already noticed that acceleration is equal to rate of change of velocity over time. Making velocity subject will give you the acceleration and time. Now describe how the velocity of an object can be determined using light gates. Set up the light gates vertically and measure the distance between them. Connect them to a data logger and then release an object from rest above them, measuring the time it takes for an object to travel between the two gates. Using the time and the unknown distance, you can calculate the velocity of the falling object by using the equation velocity is equals to displacement over time. A ball is projected off a castle at 6 meters per second. How does its horizontal velocity change from its launch until it hits the ground? So the horizontal velocity remains the same as there is no acceleration in the horizontal direction. You need to think about it in your projectile motions. In projectile motion, what is the vertical acceleration? So the vertical acceleration is equal to gravitational field strength downwards, where the gravitational field strength of Earth is negative 9.81 meter per second square. At the last, you need to acknowledge how to derive and also memorize strictly these 5 accelerated equations. Make sure that in your paper 2 and paper 4 you always get the 2 accelerated equations and above 3 you need to remember. Where S is displacement, V is the final velocity, U is the initial velocity, and A is the acceleration, and T is the time taken. S is equals to ut plus half at square. The second equation is V is equals to U plus at. Third equation is V square is equals to U square plus 2AS. This fourth equation is S is equals to Vt minus half at square. And the fifth equation is S is equals to half U plus Vt, where the U and V are adding and T is multiplying. Now before ending this video, I want you all guys to make sure that in your AS level and also in your A2 level physics, you are strictly required sometimes to derive an equation and you need to show the derivation and also show the step very neat and clearly, and what the equations are you using. You need to mention that equations. For suppose you are using V is equals to initial velocity plus acceleration multiplied by time. That's the second equation. Now you are writing this equation on the paper to show the examiner that you are using this equation basically, and obviously you will get your mark, maybe C1 or M1. And if you don't show these equations what are you using, you will never get a mark for it, and 1 mark or 2 marks may be deducted. So be careful while solving the paper and also try best doing solve past papers. If you have any problem, make sure that the comment section is always open for you guys, and I am also sending you few questions on your descriptions of this video and also on my community post. So that's all about your flashcards which I prepared myself, and I got a best grade in my A-level physics. I want you guys also to improve yourself at the first attempt. I want you guys to do solve past paper. By doing solve past paper and also seeing the mark scheme and the marks given to you, including the examiner report, as I was instructing you guys for your best grade in your AS physics. This will help you a lot, will show you that how the examiner wants you guys to derive the equation as shown in the marked scheme, and each mark is also given for each step. It means that it will be very helpful for you to show each step. If you miss any one, you'll never get any mark. We'll see you in the next video. Till then, take care.